Hey guys, we're going to work on 8.2. This will be proving that triangles are similar, and we're going to learn a theorem called angle-angle. It's not bad. Okay, this part we talked about last class. What are similar polygons? Similar polygons are two different polygons. They don't have to be triangles. They could be rectangles, squares. They could just be quadrilaterals. Any two polygons that have all their corresponding angles are congruent and all the corresponding sides have equal ratios, okay? Which means they are proportional. That's what that means. If the ratios between the sides are always the same, then they're proportional. So we'll call this triangle cat, this triangle dog. Okay? I'm going to tell you triangle cat is similar to triangle dog. That means all the corresponding angles are congruent. So go ahead and write the corresponding angles. Notice when you do this, they match up, right? They always match up. I'm getting pencil, sorry. So, I can't find one. Angle C, angle D, they're both first in the list. Angle A, angle O, they're both second in the list. Angle T and angle G are corresponding. So you have to make sure you write the similarity statement so that the vertices are in the correct order. Okay. The second part is the sides, all the corresponding sides, the sides that match up have to be in the same equal ratios. Okay? So side CA, right, would match up with side DO. CA and DO, the first two letters. I'm going from this left side to the right side triangle. The left triangle to the right triangle. Okay, that's the order that I'm doing this, left to right. So the ratio of these two has to be the same as the ratio of these two. So these would be CT, and if you notice, first and last letters, DG, first and last letters. Okay, and that would also have to match, be equal to the last pair of corresponding sides, which is AT to OG. AT, OG. That will come in handy later when we have to find the lengths of sides. Okay, so if I want to prove that two triangles are similar, I would have to prove 1, 2, 3, 4, 5, 6. I would have to do all of this to show that they're similar. But dun, 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 we don't have to, okay? If we can say that only two of the corresponding angles are congruent, that's all we need to do. That would mean then the triangles have to be similar, okay? If these two are congruent to these two, that means the third angles have to be congruent. If all three angles are congruent, you know the two triangles are similar shapes. So when we write this, if two pairs of corresponding angles of triangles are congruent, then the two triangles are similar. Okay? So we only have to have two pair. One pair, right? Two pair. Here's your second pair. So because angle B is congruent to angle E, and angle A is congruent to angle D, we know that triangle, now the order matters, right? And it's, just similar, not congruent. The triangle is similar to the triangle. I'm going to start with the one curve, go to the two curves, and then to C. So I'm going A, B, C. When I complete the similarity statement, I've got to go in the same order. So I'm going to go D, E, F. Order matters, okay? Let me white out that real quick. I had a student tell me the name of that shape right there. Forgot already, okay? So this means congruent. This symbol here means similar. Okay. Now, let's do some work. That's all the new stuff that we have to do, okay? Are the triangles similar? If yes, write their statement. Okay, if I look at this, now here's what this question did. They used B and B prime to show you that they kind of match on top of each other, C and C prime. If I were to split these two triangles, okay, there's A, B, and C. And then the other one, okay, the larger one that it's inside of, okay, I've got A, this is B prime, and C. So I've got these two separate triangles. This is one curve here for A, and it's also one curve if I split it up, right? This B has two curves, this B has two curves. So I've got two pairs of corresponding congruent angles, right? Write the similarity statement. So yes, okay, they are similar. I have two pairs of congruent corresponding angles. Okay, that's why. And then I'm going to write the statement. So I'm going to go A, B, C is similar to triangle. This one's A, B prime, C prime. They're not always going to do that this is like from the workbook. They're not always going to give us those. This is very similar to this one. I've got two triangles again. If you need to see it, use highlighters, figure out how to get it done, okay? I've got this triangle here, right? I've got that top of the diagram, and then I've got the whole triangle. So I could split these up. I've got a yellow triangle, you can't really see it, and an orange triangle. So I'm going to redraw it. I've got the top, and then I've got the whole thing. They both have a 52-degree angle, and they both share this angle A, right? They both have angle A. So angle A is here, and I know that this 52 is congruent to this 52. So yes, we have two pairs of congruent corresponding angles. Okay, and then the matchup. I'm going to go A, B, E is that top one, is similar to triangle A, C, because these are congruent and these are congruent. A has to match with A, that's reflexive property. A, C, D. This one I still got the same thing going on, but now you have to use your golden rule, right? Your golden rule for triangles is that the total of the angles is 180. So if I use 64 and 90, that gives me 154. 180 minus 154 gives me 26. So this angle here has to be 26. That means I've got two pairs of congruent angles. I could say 90 and 90, 26 to 26. This one's also 64. Okay, so are they congruent? Yes. Why? Two pairs of congruent corresponding angles. Okay, this one's going to be harder. So I'm going to go ahead. This is 2690. I'm going to write the 64 here. Sorry, 64. Now when I do this, it doesn't matter where I start, but I just have to make sure when they match up, they're in the correct order. So I'm going to put triangle CDE is similar to triangle. C has 26 degrees, so I have to start with K. D is 90, so I have to do G. E is 64, so I have to go to H. Okay? So triangle CDE is similar to triangle KGH. There you go. Okay, you guys do the same kind of idea on this one. You've got to remember you've got vertical angles. Look at that. You could also look at parallel lines cut by a transversal, and you have alternate interior angles congruent. You could do that. This one, not bad. This one, you're going to have to do the same thing. Use your golden rule here. Okay? So they have to total 180. So this is 58. If this side's 90, this side has to be 90. What are these two? To have two pairs of congruent angles. When you match them up, pay attention. I want to do, okay, I think the rest of these are okay. Okay, I'm going to do one of these down here. These I would split up. I would draw the two separately. That might help. Okay, but I would like to do this. A free fall ride casts a shadow. So I've got some kind of ride. I don't know what it looks like. Okay, there's my ride. Here's my sun out. And the shadow is on the ground. The shadow is always on the ground. Okay? And it casts a shadow that is 80 feet long. Okay? At the same time of day, so the sun height and the angle of the sun coming off will be the same for anything outside at that time. Okay? A person is 5 feet 5 inches. So I've got, here's a person. And this person is 5 feet 5 inches. And their shadow is 34 inches long. Okay, now we've got a problem. Okay? Here I have 80 feet. Here I have 5 feet 5 inches. Here I have 34 inches. So we either need to make it all to feet or all to inches. Okay? So that's going to be our hard part. Let's draw the triangle. We'll come back to that though. Let's get this done first. Okay? Because the sun is coming down on this, these angles are the same. Okay, whatever that angle is. This angle is equal to this, and we're assuming the person is perpendicular to the ground, and their ride is perpendicular to the ground. So the two triangles are similar because of the angle-angle theorem. Okay? So I know the triangles are similar. Because they're similar, it says how tall is this ride? How tall is it? I'm going to put an X here. So I can write a similarity statement that goes X is to 5.5 as 80 feet is to 34 inches. But I got to change these to make them all in the same measurement. Okay? How about we do If we do 34 inches to feet, okay? We go 34 inches and we make it to feet. So I know there's 12 inches in a foot, right? So 12 goes into 34, not quite 3. It gives me 24, and I get 10 inches left. I got 2 feet, 10 inches. Okay. Yes, how about we just change it all to inches, and then we can move it in the end. Let's do that. That'll be easier. Okay, let's forget that. Let's just go 5 feet, 5 inches, means 5 times 12, which is 60, plus 5 more. So this person, right, is 65 inches tall. And then the shadow is 80 feet. So I'm going to go 80 times 12. Okay? Get your calculator, punch it in. I think it's 960, right? 80 times 12. Yep, 960. So this is 960 inch shadow. Now we're good. So I've got inches, inches, inches. So I'm going to write my ratio. Go back to this. If triangles are similar, that means the sides, the corresponding sides, the matching sides, when you write the ratios, they're always going to be the same. So CA is to DO. That has to be in the same ratio as I would do like AT to OG, right? AT to OG. Or I could do these two sides, the matching sides. The ratios are always equal, which means that they're proportional. If their ratios are always equal, it means they're proportional. So I'm going to come back to this, and I'm going to go height to height. X is to 65 inches as shadow on the ground, 960 inches is to 34 inches. Then we're going to do cross products are equal. 34 times x equals 960 times 65. Okay, so let's do it. I already have 960 in there. Times 65. 62400. Oops, here. 62400 goes right there. Equals 34x. So I've got x equals 1835.3 inches. Now that's kind of crazy, right? Like I can't picture that. That's a lot of inches. So I'm going to go ahead and take that and divide it by 12 so I know how many feet. So my ride is 153 feet tall. Okay? So this one, number 6 and 7, are very similar to number 5. When you do this, it's the same kind of thing. The height of a building, right? And it tells you a building is 1,250 feet tall. Your friend is down here, okay? And is 6'3" tall. Standing nearby a shadow that is 33 inches long. What is the length of the Empire State Building shadow? Okay? So you're going to do the same idea. You got triangles. They are going to be similar. And then you have to go ahead, change everything, I don't know, to feet or to inches, either way. And then change it back to feet when you're done. Okay, good luck, you guys.